Hey, how is it going, everyone? This is Christina. Recently, I did a talk in Kafka Summit APAC, introducing Kamelet to the Kafka audience. I would also like to share that with you and my thoughts on the Kamelet and why is it good for Kafka users. But it's like any other Camel technology out there. You can use it basically on anything such as orchestrating serverless, creating microservices, or basically just do anything with integration. So what Kamelet is, it's basically just defining a template using a camel route that you already know. So the other users can use your template to create the camel instance based on the variable they're setting into the template. So this works especially well in the cloud native world, but Kamelet also works very nicely with Kafka. So here we go. I'm going to tell you my thoughts on why you should use Kamelet for connecting to Kafka, especially when you want it to run on a cloud native system, especially on Kubernetes. You can always skip ahead to the demo at the end of the video if you want. So, you decided that you're going to stream your data in real time with Kafka. Then you started deploying and then finally got your pretty shiny new Kafka working. But what next, right? It's like you have a nice coffee shop open, but no customer. Or, well, here really what I mean is there's no events or data going into Kafka. It is not going to generate any profit at all, right? So, to make most out of your Kafka, you need to get it started to connect to other systems you already have. Yes, like the new applications out there that's connecting to Kafka, you can have them connected to Kafka directly with the libraries and everything. But what about the legacy ones? What about the packaged software that your company bought? What about these SaaS services that you recently purchased? To achieve the ultimate utilization, it's often up to you to stream events from or to these places. And that is what I will propose today, using Kamelet. And not only use Kamelet to connect to Kafka, it also works with sending cloud events to your Knative channels or broker as well. Kafka is blazingly fast, as it's optimized for writing streams data in binary format and basically quickly logging everything directly into the file system. And it minimized effort to process what's in the data, so that's why it's super quick. So Kafka itself is supercharged at making sure data is stored as quickly as possible and quickly replicating it for a large number of consumers. And that's what Kafka is focusing on mostly. But when it comes to communications connecting to different resources, it's not Kafka's forte. So for the clients that wants to stream data into Kafka or out of Kafka, they have to be smart. Here is what the client typically need to do when they try to stream data into Kafka. First, they need to connect. By connect, meaning that they have to talk in the destination protocol and the Kafka protocol, which means it also needs to include the libraries in order to talk to the source, the sink, and Kafka. As well as that, it needs to convert data. So it needs to serialize and deserialize data because Kafka stores data in a binary form. So you want to serialize it into a binary data. And once you've done that, you also wanted to make sure that you're sending the right data into the topic. Therefore, you want to check it with the schema. So validation becomes another part of what you should do, what the client would do when it tries to send or receive from the topic. As well as that, it needs to transform. So this one looks a little bit deeper into the actual context of the data, meaning that it makes simple changes to the individual data chunk. Normally, you would do some filtering. Sometimes you want to split it depending on what you want to do. And also, you want to do some error handling. So if in case something happens or something wrong, you want to make sure that the problem has been taken care of instead of just left it without being processed. It could cause a problem in the future. And once you get your client set up, it's time to deploy it. So how to deploy that into Kubernetes could be a problem. And then you also want to make sure that it is monitored so you're informed of what's going on. And also when you have more than a couple of hundreds of connectors trying to stream data into Kafka, how you're going to manage all these clusters or all these clients trying to talk into Kafka would be another issue. And also scaling up your connectors or the clients where if you want to have more clients handling the streaming because of the load, you want to be able to do that. And as well as that, you also want to take care what other connectors can be used to connect to Kafka. And once they're not in use, you want to put them away in a repository so you can reuse them in the future. And getting things onto Kubernetes is not easy. Like what I said before, it was easy to run it as a standalone, but what happens if you need to containerize it? And I'm not even going to go through all the things you need to configure in order to run that on the Kubernetes or OpenShift environment, and the steps you need to go through while troubleshooting it. If you map what Camel does and what the connector has to do in order to talk to Kafka, you're gonna see a very big similarity of what Camel does and what Kafka connectors or connectors trying to connect to Kafka do. First of all, the connectors, where it's going to talk in different protocols, where Camel already has 300 plus of the connectors built in for you. Basically, just pick whatever connectors you want in Camel, and it will include the libraries you need, as well as libraries that's talking to Kafka. And also, Camel contains transformation built in, so depending on what libraries you want, Camel will pull in the libraries to serialize and deserialize it into your Kafka topics. And for the transformations, obviously Camel has enterprise integration pattern that helps you to filter or even mask what's in the data chunk or what's in the data payload for you. And Camel also does the error handling like dead letter queue for a very long time. And Camel fits perfectly in this realm for connecting to Kafka. So you ask, how do you write the Camel since it's that powerful? Well, basically what you need to do is to write Camel routes. So setting up Camel routes is pretty simple, right? Basically you write where it's coming from, say a topic, and where it's going to, say, a RESTful services. And then in the middle, you can do some kind of transformation, like turning a binary format into a JSON, and then mapping it to using a drag and drop tooling to map between two different data formats and do some kind of validations before you send it out. And then once you have that done, you can define all the libraries you need in the POM file or any business logic in the POJO. And then you can add the runtimes that you prefer to run it on, either Spring Boot or Quarkus or just plain old Java runtime. And then once you've done that, you can deploy that onto your environment using Maven plugins. So it's very easy for you to deploy things into Kubernetes. And basically that's what you need to do for Camel. Well, so this is when the Kafka users comes in and say, all right, so I'm very good at setting up Kafka and I know how to do data, but I don't really feel like coding because I do a lot of configuration. Configuration is fine for me because I do that all the time. But I just want to move data from one endpoint to another. Do I have to code? What I'm going to offer you today is pretty fun. So we basically give you a marketplace of things you get to choose from. On the shelf of this marketplace, it contains all the things, all the templates, anything that you want in order for you to choose from in order to connect wherever you want to connect to or from to Kafka. So basically what you need to do is pick one of the connectors that you want to use from the shelf of the marketplace, and then put in your variables and then deploy that onto Kubernetes. It will then connect the world to your Kafka or connect your Kafka to the world. So as a Kafka users, what you need to do is define Kamelet binding. So Kamelet binding is a configurations. It's not a code. It's in the format of YAML. You need to define the source and the sink. The source is where the data is coming from. The sink is where the data is going to. In this case, I'm going to talk to, for instance, a Telegram. Then I'm going to use the Telegram template that I got from the marketplace, and then I'm going to send it to a Kafka which I already built, and vice versa. So when you want to stream your data from Kafka to Kamelet, say I want to send it to Salesforce, then what I'm going to do here is I'm going to say, hey, the source is coming from my Kafka, and I'm going to pick the Kamelet from the marketplace shelf, place in my credentials, and then once I'm done with the configurations, I'm going to push these configurations. The operators on OpenShift will take over, and it's going to do all the deployments for me. So then based on your configurations, going to the source of where you're choosing it from and then streaming it into Kafka. vice versa. You can also use Kubernetes to scale up all the connectors, to manage all your connectors, and then monitor all your connectors as well. So this is what the Kamelet binding look like in real life. That it's very simple to understand, like it's in a full YAML format where you have source and sink. Source is where you're pointing the source is coming from, and sink is where you're pointing your sink referencing to. It is referencing to a Kamelet core Salesforce. So this one will be developed by your integration developers or people contributing to the Camel project. And then in the sink, I have it linked to another template where it's going to send the data into a managed Kafka environment. This is a special Kafka instance that's provisioned and hosted by Red Hat. But again, you can always reference it to a local Kafka instance if you want. And for those people who's curious, or if you are a Kamelet developer or people that wants to start developing the templates, this is what the actual Kamelets look like. So as a Kafka users, you don't have to understand this, but if you want to see what's going on inside that template, this is what's going on. On the top part, you would have a place where you're going to define what is my Kamelet call. So this is where you're going to define your names and other things like if you're using any tools, it's going to define what a UI will look like. It's providing more of a metadata, meta info kind of thing for the Kamelet. And then you would have to specify the data shape. For instance, what kind of variable you're configuring in this particular Kamelet, right? So what kind of data you're receiving, what kind of variable you're expecting, right? And once you get that figured out, then we go to the meat of Kamelet, which is defining the behavior of this template. So basically, as you can see, it's in the form of camel routes. It has a from, so where it's getting its data from, and here I'm using Telegram, and all the authentication, the tokens, the credentials were given to me by the variables defined on the top, where I need to get that from the users. So as a person using the Kamelet will need to provide all this to me, and the destination will be whatever that was set in my Kamelet binding, right? So very simple, and this is what the integration users need to do. But as a Kafka users, you don't really need to understand that. So once the integration developers finish developing, they would end up with lots of Kamelets that's connecting to everywhere. So if you take a closer look to that Kamelet, you'll see it's doing a couple of different behaviors, if you remember what we just told. So it does some connection. So it talks to Telegram. So it will load all the Telegram libraries for you. And then what it does, it's going to convert to a string. And then here I'm going to do some transformation by filtering out all the empty strings. And then there's error handling, which in this case I haven't done it, but you can also add that in there. So once you've done that Kamelet, these developers can now then place all this Kamelet and then install them on OpenShift. So OpenShift will then become this great marketplace. So as a user, you can go up to onto OpenShift or Kubernetes and then find out what are the Kamelet that's available to you. You just need to configure that. So what happens on the Kubernetes or OpenShift environment? Once you deployed, the operator on the OpenShift environment is going to notice that, hey, this Kafka users has defined a Kamelet binding, and I'm going to go and then start up a pod. So you have a running pod that's running all the logics. It's now streaming data from your source to your destination, which is Kafka. But what's running inside that pod, you ask, right? People are curious, so let me lift that mystery box and show you what's going on, right? So here I have a camel context, so I have a camel running. It has a couple of different Kamelets, so it will then fetch all the Kamelets, and the Kamelet will have libraries that you need to connect to source, and the libraries you need to connect to sink with everything that you have just configured in your Kamelet binding. And it is going to then use the Quarkus runtime, so it's going to use the latest and fastest runtime available out there, so it will start really fast. And as well as you would also have other libraries included if it needs, as well as the other monitoring libraries that's needed to run this pod. And speaking of managing on OpenShift, it's really easy to scale up and down with how many pods you're running, and it will then And based on your configurations, you will be able to stream the data into Kafka, or you can send it into any Knative brokers or channels, since we're talking about event-driven here, so it will automatically detect where your channels and where your brokers are. Or you can also connect to external managed Kafka service by applying service binding, which is providing some credentials and where it is, and it is going to automatically connect to that. So, and that is what we will be doing in the demo by connecting to an external managed Kafka. And that's it. Once you master Kamelet, you'll find it super easy to use, and it will be super easy for you to now streaming everything from SAP, from Twitter, from anywhere on the world, ServiceNow, Salesforce, and then streaming all the data into Kafka. So let's go ahead and then start the demo. The demo is a very simple scenario where I have people in APAC listening to notifications for a lot of campaigns. The campaigns are entered from the headquarters into a Salesforce system. Then inside Salesforce, once the campaign has entered, it's going to kick off a bunch of internal processes, but then it will also notify all the end users that's listening to the notification. And because the users reside in APAC, therefore, to overcome the language barrier, we decided that we will translate a lot of the campaign informations into multiple languages that the people would recognize. I have designed this demo architecture to be event-driven. By streaming real-time campaign creation events into the Kafka topic, I'm using OpenShift Streams for Apache Kafka, which is the hosted service by Red Hat that not only the host but also manage your Kafka cluster for you. So as a developer, I no longer have to worry about the installation and management, but only needed to create the clusters and topics as I needed. Then I'm going to use one of the Kamelet that is already being installed on my OpenShift environment, aka the marketplace. With the credentials and configurations in the Kamelet binding, it will start a Kamelet instance that streams the campaign events into the Kafka topics that I created on the hosted Kafka service. Notice that we are working with 3 different clouds: Salesforce, Red Hat hosted service, which is the Kafka instance, and then my own cloud, which is doing the streaming. Now let's go ahead to the Red Hat OpenShift Streams, which is the managed Kafka platform hosted by Red Hat. We're going to start by creating a Kafka cluster. We're going to give the cluster a name, and then we know it's going to be hosted on AWS as the underlying infrastructure. And while we're waiting for the cluster to start up, we can take a look at some of the details on where it's deployed, and also some connection details if we want to use it later on to connect to this cluster. Once this cluster is up, I'm now going to create a new topic. I'm going to use this topic to get events from Salesforce, and we can define the partitions and also the retention time, and also it's going to tell us the how many replica class is going to set it up for us for the high availabilities. Now we're going to go ahead and create a service binding, which binds the service directly to the managed Kafka cluster I just created. So in our local OpenShift environment, where I'm going to run all the connectors and services, I'm going to go to the managed service and then start setting up my bindings. First of all, I need to provide some API tokens, which is the credentials to log into my managed service account. Now once it's set up, I can now connect to that account and I can see the clusters that I spin up. I'm going to choose that. Now I have successfully bind my service from my environment to the external Kafka cluster. And we can see that there is a Kafka connection already created on my OpenShift environment. We're going to use this as the configurations and credentials to connect to. And you can see that all the credentials and config are stored in the secret, so it can be retrieved later on. We have the topics ready. We're now ready to stream data from Salesforce into the topic. Here is a glance of what the marketplace would look like on OpenShift. I have preloaded all the Kamelet from the Camel community, where we have a bunch of contributors creating the Kamelet for us. But of course, you can always create your own. As a Kafka developer, what you need to do is defining the Kamelet binding. Remember that we said about adding your credentials. So here we're just adding the credentials of what you had in Salesforce and also linking it to the service binding that we have just set up in the beginning, where it's going to link to your managed Kafka. Let's go ahead and then push that Kamelet binding onto OpenShift or Kubernetes. And once that's done, you can see now the Kamelet instance has started, and now it's ready to stream data from Salesforce into the Kafka topic. If you take a look at the service binding, you're gonna see there is a new service binding object created that specifically points to the Kamelet that we have just defined, where it will contain all the configurations needed to connect to the managed Kafka, like the bootstrap address and the credentials. Now remember what I said about the operator is going to take over and then turn your Kamelet binding into a running pod. So this is the pod. So you have a running Kamelet applications now ready to go. Next, I am going to show off a little bit, because now I'm turning all the events coming from Kafka topics into cloud events, so that I can turn all my translation service that's talking to AWS into a serverless function. So I'm gonna go ahead and start to create two channels. These are the channels that is going to receive cloud events. But we need to have something that turns what's coming from Kafka into a cloud event, so the channel will recognize it. I'm gonna start by picking up another Kamelet from the marketplace, which does the transfer between topics and cloud events. So a lot of information was given to me from Salesforce and everything about the campaigns, but I don't want it to be translated because it's gonna cost me money. I'm just gonna pick whatever is important, and in this case is the title of the campaign. I'm just gonna filter it out and then do the translations. After providing the endpoints of both ends by telling the Kamelet where to go and where to send, it is going to start up a pod that is going to actually stream the event from Kafka topic to the cloud events. Next up, we're going to do the translations. So the translation service will contact the AWS translation cloud services and is going to do the translation for me. And if you take a look at closely into my marketplace, we have a couple of already built-in translation Kamelet already in there. I have one is translating Japanese, one is translating Korean. So I'm gonna take that, giving it some of my configurations, like where to pick up all the events, and then once it gets the information back from AWS, it's going to write to another cloud event channel, which will have all the translated result, and I'll be using that later. But take a look at all the pods that I have just spun up. These are all serverless pods, meaning that they will scale down to 0 when it's not needed, which means that it will optimize our resource utilizations and ultimately saving us some cost. Alright, now we are going to connect to the Telegram, which are the endpoint device that people will receive the notification. As always, you'll find the Kamelet in the marketplace. We are going to reuse it by specifying the Telegram credentials in the Kamelet binding and then push it to OpenShift. Once the poll has started, now it's ready to get the cloud events and then give the translated results back to the Telegram. Before we start providing campaigns in Salesforce, let's log on to the Kafka topics managed by Red Hat and make sure that it's receiving the events correctly. Once we're done, we can go ahead and log on to Salesforce and provide a campaign name in English so it can be translated later. As you can see, there's no pods running because there's nothing to translate. We're gonna click save. As soon as we save the campaign, you will see the events has been sent to Kafka right away. And then if you go to the pod, you now see the pods are now starting up because it's now translating the campaign informations, and the campaign names are now sent to telegrams. Now things gets very flexible from here. If we want to add 2 more languages translated into Telegram, all we have to do is to create 2 more bindings with the specified languages, in this case Russian and Chinese. And once everything has been pushed to OpenShift, now it will translate 2 languages. We're gonna create another Salesforce campaign, again in English. Now you see the events has gone into the Kafka topics, also waking up all the translated pod, and the results has come back with additional Chinese translations as well as the Russian translations. And that concludes my video of today, where I show you what Kamelet is and how to utilize the marketplace of Kamelet to connect your Kafka to the outer world, and how easy it is to set up and how you can scale it down and up on the Kubernetes environment. And I hope you find this useful and tell me what you think about this video. Thank you very much, and I will see you next time.